Here we are asked to find out which equation will have the higher y-intercept, or in other words, greater y-intercept. Okay, so here we go. We see that this one is in standard form and this one is in vertex form. We can pull the y-intercept out of standard form pretty easily. It is always if you're given ax squared plus bx plus c, the y-intercept is always equal to c. Well, if we look, we have a, we have b, and we have no c, so that means 0. So we have plus 0. So that means that our y-intercept here is 0. For this one, for the vertex form, we have to do some work. We first have to expand this, then do this, and then finally combine this until it's in standard form. So let's try that out. We're going to do x minus 1, quantity squared, which is x minus 1 times x minus 1. If I expand that out, x times x gives me x squared. X times negative 1 gives me negative 1x. Then I have negative 1 times x, which is negative 1x. And then we have negative 1 times negative 1, which is positive 1. Combine like terms here, we get negative 2x. So I get x squared minus 2x minus 1. But I still have the negative 2 and the plus 1. So these are from the original equation. So now we distribute this through. So I get negative 2x squared. Negative 2 times negative 2 is plus 4x. And negative 2 times negative 1, I'm sorry, that should be positive 1. And negative 2 times positive 1 is negative 2. And then I have the plus 1. And combine like terms, negative 2 plus 1 is negative 1. So we get the final standard form equation of negative 2x squared plus 4x minus 1. And that tells me that my y-intercept is negative 1. So the y-intercept for g of x is negative 1, which is to say that the function f of x's y-intercept is higher, forgot, the function f of x's y-intercept of 0 is higher than the function g of x's y-intercept of negative 1.